Day 63 Notes, Advanced Algebra 2. Today we continue our discussion with polynomial unit, and this practice today will be solving polynomials using a calculator. So I want to go through a few examples in this video, and that way you'll be well prepared to complete the activities for tonight. Now, before we go to the graphing calculator, let's predict what each will look like. This will be using the same technique we used on Friday's quiz. Then, after we predict what each will look like, we'll go to the calculator to determine the real zeros, real number zeros. Now, what we have here in this first example, f of x equals x cubed minus 3, is a cubic binomial. And the leading coefficient is positive, and the degree is odd. So if we're thinking about what this shape might look like, we should recognize by end behavior and the degree perhaps what this will be. Because the leading coefficient is positive and the degree is odd, I know my tails have to go in this direction. And because the degree is 3, I know I can have at most 2 turns. So this is a picture of what the graph might look like. Don't forget that when we use a graphing calculator to solve this expression or find the real zeros, what we're looking for are the x-intercepts. So we could have up to 3 intercepts here if the graph turns in this direction. Now, we don't have to have 3 intercepts. In fact, if you were sketching this picture on your own, you might recognize that even though the tails go in opposite directions, if we have, let's see, the 2 turns that we discussed, turns could occur way up here, for example, and our solution would only be 1. We'd have one solution for this example. So there are lots of different ways that we can sketch this graph, but it's important to recognize that at most we will have 3 solutions if it curves twice and it curves in such a way that the line crosses the x-axis 3 times. Let's switch over to the graphing calculator and take a look at this example. I've just created a TI Inspire document, and I've included one graph page. So the first thing we need to do is press that tab key so that we can get the entry bar available. And I'm going to press x cubed minus x as the entry value, and I'll press enter here. And here's that picture of the graph. We see that it does cross the x-axis 3 times. Now, we could move forward and find the solutions from here, but I'm actually going to zoom in a little bit so that we have a better view of the graph. So let's choose Menu, Zoom, and In, and I'll pick the center of my zoom to be right here at the center of the graph. And I'll do that again, and maybe one more time. That's good. Now I can clearly see the 3 intersecting values that go along with the x-axis. Our objective is to find the zeros of each of these graphs, so let's go ahead and go to the menu, analyze the graph, and choose 0 as our option. Now I think that there's a 0 that occurs right here, so for the lower boundary I just need to pick a position somewhere to the left of that, and then I'll move over and select a position on the right. This gives me one of the zeros. We'll repeat this process, menu 6-1, to find the remaining zeros. There's the other, and finally the third, menu 6-1, and we've got the 3 results. Keep in mind that when we identify the zeros of the graph, we should consider the entire coordinate. Each of these do represent a 0, but as far as the solution in terms of x, the answers are simply the x values. So zeros occur at -1, 0, 0, 0, and 1, 0. The x values, or the x solutions to the equation, would be -1, 0, and +1. So as an answer here, since we were asked to find the real number zeros, we'll say that real zeros are at -1, 0, 0, 0, and 1, 0. And that would be a good solution to problem number 1. Let's try the second one. This time we have a cubic trinomial with a positive leading coefficient again and an odd degree. So it too will follow the same pattern that we saw in the last example. It could look just like this. The tails have to face in opposite directions, and it's down and to the left and up and to the right in this case, and we could have as many as 3 zeros. Now again, we could have 2 zeros, we could have 1 zero, but we could have as many as 3. So let's switch to the graphing calculator and determine this result. Over here at the graphing calculator, I'm going to clear out the last entry. So I'll press Tab to bring up my entry line, and I'll press the up arrow and Control Delete to clear out that equation, and I'll press Enter here. Now don't forget that we zoomed in quite a lot for this last example, so I'm going to return this window back to standard view. So I pressed Menu, select 4, and now 5 to go back to standard. And now we'll enter the equation. And that equation was 3x cubed plus 2x plus 1. And there's the graph. Notice we only cross the x-axis one time in this picture. We still have the two curves or two bends that we expected to see, except this time they're not quite as extreme as what we had suspected. But that's okay. We can still find the solutions here in the same method that we did before. Let me zoom in just a little bit so that we can get a good idea for where this 0 occurs. And now we'll use the menu 6-1 option to find the zeros. Here we have a solution. A real number 0 occurs at -0.402. So we would say that there's a real 0 at -0.402, comma 0. Again, our estimate here, or at least my estimate, was that this would have a little bit more of an extreme curve to it, but they weren't quite that extreme, and we only had the 1, 0 value here on the left-hand side, and that's perfectly fine. Let's look at this next example. This time we have a quartic trinomial. The leading coefficient is again positive, and the degree is even. So when we're picturing this graph, we know that the tails have to go in the same direction, and they have to point up in this case. Since the degree is 4, we can have as many as 3 turns to it. 1, 2, 3. This will form a W graph. In this case, we can have as many as 1, 2, 3, 4 intersections with the x-axis. Although it's possible too for the intersections to not be that many, or the curves to be not quite as extreme. Here's another example. If I point both tails upward, I could have one curve come way down below the x-axis. The other one can come up and barely touch the x-axis and return off to the right. And in this case, we could have 1, 2, 3 real solutions. Or if that x-axis was just a little bit lower, we could have just the 2, or maybe even 1. Let's go ahead and graph this and find out what the real zeros are in this case. Again, I want to clear the last entry, so I'll press the Tab key, go up to the last entry, press Control Clear, and Enter. Then I'd like to return my window back to standard, and now I'll enter the expression. x to the fourth power, and I believe it was plus 8x, but I better double check. No, minus 8x squared plus 1. So minus 8x squared plus 1. We'll press enter from there. And here's that W graph, although we can't see the bottom curve of it. So what I might do here is adjust the window. Let's fit it so that it goes 3 units to the left, 3 units to the right. So we'll go Menu, Window, change the settings to -3 to +3. And I'll just press enter here. I'm satisfied with the horizontal direction, but not the vertical direction. And the nice thing about this calculator is we can set the vertical zoom, or the range of values in this vertical direction, by allowing the window to fit the X direction. And that's what this command does for us. So menu for, and then option A for zoom fit. And what that does is it reduces the values in the X, or in the Y direction, so that we can see the rest of the shape of the graph. Now we need to analyze the graph and find each of these zeros. So here's one of them. Oops, we want analyze, option 1. There's another 0. Menu 6, 1 for another. And menu 6, 1 for one more. And here are our 4 zeros at -2.81, -0.356. So we have -2.81, 0, -0.356, 0. We have +0.356, 0, and +2.81, 0. And these are our real zeros for this example. Let's take a look at another. Here we have a 5th degree polynomial. Have to call it a polynomial this time because it has more than 3 terms, and we have to call it a 5th degree because we don't have any special names for this. Now what's interesting here is that we have a leading coefficient that is negative, and we have an odd degree. So when it comes to previewing this shape, before we even go to the graphing calculator, we should have an idea of what this looks like. Because the leading coefficient is negative and the degree is odd, the tails have to go in opposite directions. Since the degree is 5, we can have as many as 4 turns, so we can think 1, 2, 3, and 4. This could be a picture of the graph. It could be less extreme than that. It can have only 2 turns. We saw that that's possible based on our investigation last week. And it could have the turns that occur way up here too. We just don't know until we get into the graph itself. I'm going to guess that it's going to look something a little bit more graceful like this. And let's see what it looks like when we go over to the graphing calculator. So menu. Another way to clear out all of our work is to go to the Actions option and delete all and tell it yes. And now we can zoom back to standard, and we will bring up our entry bar. This is -x to the 5th, and let me double check the other ones, -4x cubed, plus x, and was that a +5? Yep, +5 at the end. Aha. So here we go with the graph. It appears that it only has 2 curves. Let's zoom out just to be safe here. In case there was a curve somewhere up there, I need to verify that. But by zooming out, it doesn't look like there are any more. So what we have is only 2 curves, even though the exponent was 5. Let's go ahead and zoom back in. And this time we're going to pay attention to the zeros. We're only interested in where this crosses the x-axis. So we'll analyze graph, find the 0, and that's here at 1.06. So there's a real 0 at 1.06, comma 0. I'm going to pause the video and complete one more example. I'd encourage you to do the same. Here's a screenshot of the graph you should have encountered, or something very similar. Your zoom would have been, or could have been, different than what I have here. But what we find with this graph as a negative leading coefficient and an odd degree, the tails point on opposite directions, and we have as many as 2 curves. So here's 1 and here's 2. With those 2 curves, we created 3 real zeros. So here's 1, here's 2, and here's 3. Now, the last thing to consider before we finish out this video tonight is I want you to think of these 2 discussion questions and be prepared to talk about them tomorrow in class. If I ask you what's the degree of the sum of a quartic polynomial and a cubic polynomial, could you answer that? Is there a single answer to this question? What's the degree? What will the degree be if I add together a quartic polynomial and a cubic polynomial? And then the other question I want you to think about is the sum. So when I add together 2 trinomials, is the sum of 2 trinomials always going to be another trinomial? Add these notes, or add these questions to your notebook. Be prepared with an answer tomorrow. That's how we're going to start our discussion. Thank you.